We're gathering as architects in the face of a climate and biodiversity emergency. We've declared our concern, we want to act, and we have a COVID curveball to deal with as well. I thought about trying to discuss building materials with you in address of this full package of threats, but the prospect absolutely did my head in because it involves a lot of speculation on how this pandemic will play out. So I'm proposing to talk first and foremost about environmentally and socially responsible building materials and building methods, pretending that COVID is not happening. And then to finish with some thoughts on the opportunities that this pandemic presents to society, to the planet, and also to us as architects. So I'm going too fast with my slides. The World Green Building Council has for some time put buildings as responsible for 39% of global CO2 emissions. If you add that to the biodiversity decline that's attached to both the procurement of building materials and the commandeering of previously natural ecosystems to locate our built environment, it becomes patently clear that we, as architects and town planners, are key accomplices to this problem before us all. That said, we can also be key drivers for environmentally and socially regenerative change. Now, there are three main prongs to the approach that architects can take in this climate and biodiversity emergency. And you will know of some of these, or most of these. Firstly, it's to address the operational impacts of buildings. And that to date has been the predominant focus. Secondly, it's to address the impacts embodied in construction of buildings. And that's mainly bound up in the materials that we use. So specifying building materials responsibly has a far larger immediate impact in this emergency. And this is what I'll be focusing on in this talk. And finally, the most important prong is to address the size of buildings, which has the most significant impact on the first and the second prongs, but which are hardly spoken about at all by architects. I'll speak briefly to each of these before talking about how we can specify building materials that cost the earth less. So certainly the focus of the World Green Building Council until last year, as of the AIA's Climate Super Action Forum in Melbourne 7 weeks ago that Stefan mentioned, we have been improving on operational energy efficiency of buildings. That's been the focus of those initiatives towards achieving net zero operational carbon, as that relates to fixed mechanical and electrical services and loose appliances, as well, of course, to the thermal performance of buildings. So thermal performance is based on benchmarks, which for housing in Australia have been set by the BCA at 6-star, by Passive House at an equivalent of around 7-star on the NatHERS scale, by design guidelines for eco-housing estates like Currumbin Eco Village, Queensland, Beyond Today, which is in South Australia, the Cape, very close to me here in Cape Patterson, and Mullum Creek in Melbourne. And they have a benchmark of a minimum 7.5 star. And then there's also professional bodies like the BDAV that have their Sustainable Design Challenge, which they've benchmarked at 10-star. And you can see in that sort of table below that 10-star implies virtually no energy is required to heat and cool a house throughout the year. Even a superficial review of this approach raises a bunch of issues. In 2016, Swinburne Uni and sustainability consultants Pitt and Sherry, they confirmed what some of us had long feared, and that's that the value of Australia's home energy efficiency rating system, NatHERS, For the most, it's seriously eroded by lax and optimistic software data entry by energy assessors and by material substitutions and poor construction detailing on site. The Uni and Pitt and Sherry found that these practices reduce the thermal performance of homes as they're built, commonly by 1 to 1.5 stars below the certified rating. If I just quickly take you back to that scale, you could see, so if you're targeting 75%, you're going down 1.5, it nearly doubles the energy used in a year to heat and cool a home. So this weakness in the system can be addressed with a few relatively simple measures, which we employed for the Mullum Creek Eco Housing Project in Don Vale, which is an outer suburb of Melbourne. We required that energy ratings to 7.5 star be undertaken using Accurate, and that be done by one nominated independent rigorous assessor for all homes across the state that the developer nominated. And once construction was underway, we provided lot owners with a free inspection service to ensure that the thermal performance that was designed into the home was actually carried through to the final constructed outcome. Both energy assessments and construction overview were generously funded by the developer, which is a family of environmental philanthropists, Sue, Steve, and Danny Matthews. In cool temperate climates like Melbourne, it's not actually that easy to achieve a genuine 7.5 star energy rating, which Stefan and many other terrific architects discovered. So that's the thermal performance that almost halves the space heating and cooling requirement attached to the nationally mandated 6-star minimum. We found that homes with anything other than compact architectural form and a modest amount of well-oriented glazing, they struggled to reach 7.5 star without all of the following design features in place. So they needed to have high levels of insulation in external walls and roof ceilings. They needed to have double glazed or triple glazed windows with high thermal resistance and solar heat gain coefficient. And interestingly also, they needed often to have substantial and continuous insulation to lower floors if they didn't have all the other elements in place in terms of passive design, good solar design. Now, I've got my thoughts on how government should act to lock in more respectable thermal performance of buildings, but I won't bore you with that here. As architects who declare, I suggest we focus on securing as-built, say, 7.5, 8-star homes. We should do that by teaming up with highly competent energy assessors who we beg to consult without fear or favour through the design, certification and construction phases of our projects. Better that than to cajole them towards a good look but low bang for buck and frankly unnecessary 10-star standard or target. Our energy assessors also need to be paid properly for the substantial work that goes into a truly rigorous service. Okay, so what about building materials, which is what I'm supposed to be talking about? A report was tabled at the World Economic Forum in Davos in 2018, and it put the world's consumption of materials at above 100 billion tonnes a year, and that quadrupled since 1970, whilst population in that period only doubled. So between 2016 and 2018, just 2 years, this consumption had jumped by more than 8%, yet the reuse of materials had fallen from 9.1 to 8.6%. According to the CEO of Circle Economy, Harald Fiedel, who tabled the report, he said, "We risk global disaster if we continue to treat the world's resources as if they were limited." Now, the lion's share of these materials, nearly 40%, is turned into housing alone. of all the materials that are used on the planet, that we draw from the planet. So the World Green Building Council also tells us of all global carbon emissions that are attributable to the built environment, 28% are embodied mainly in the procurement of materials used to construct them. There are no clear figures for Australia on this, but from some e-tool outputs that we've played with in my office, and the work of Andre Stefan and Robert Crawford at Melbourne Uni, I'd like to suggest that the ratio between embodied carbon and operational carbon in Australian building stock is much higher than the global average. And that's because of three reasons. I think three I've got here. There might be more. One is that floor area that's attributable to each occupant in our homes and our workplaces, as well as the volume of vacant buildings in our cities and at our holiday destinations, they're higher than almost anywhere else in the world. Note from this infographic by Stefan and Crawford that as building size per occupant increases, operational energy use increases, but at a much lower rate, as you'd expect. Also in Australia, we've got a relatively benign climate that moderates heating and cooling loads. And also our newer habitable building stock, it generally has better thermal performance, better appliance efficiency, and better maintenance than that in much of the developing world, where construction has charged forward to a lower performance standard and at a blistering rate on the whole. And finally, we're advised by the Australian Bureau of Statistics that 40% of Australian waste to landfill originates from the building industry. Per square metre of floor area, and I stress per square metre, this is not per home, it's fair to say that the operational energy and water efficiency of buildings in Australia is slowly improving. What this means, though, is that the materials used to construct them remain as the primary driver to their overall life cycle environmental impact. And you can see that here on this bar chart that I've sort of built from some e-tool analysis of some homes at Mullen Creek, and also the research by Crawford and Stefan. And you can see how dominant construction is and how when we increase star rating, things don't change all that much because the space heating and cooling component of the overall life cycle environmental impact is actually relatively minor. It might reduce significantly with a higher star rating, but the overall impacts of the build are still really high. It's still not so much changed or reduced. Services and appliances, they can be upgraded to embrace new technologies and to provide improved energy and water efficiencies through what now needs to be long service life for all buildings. But our specification of building materials commonly comes with more serious, and they are immediate, environmental impacts that are irreversibly locked in as we begin construction. There are tools available to verify life cycle environmental impacts. So that's embodied and operational impacts such as carbon emissions, water use, toxicity of materials and operational practices in the building through its life, ecosystem degradation, all from cradle to grave. There might be some terrific ones out there, these tools, but those that I've engaged with can tend to draw on inflexible assumptions about the future. They can produce quite different outputs from the same data entry or entry data, sorry. And they can result in reports of only limited benefit considering the time and money that goes into them. Certainly that's the case for smaller builds. We can avail ourselves of these tools, and I expect they'll get smarter over time. But in this emergency, we could instead respond to a simple truth, and that's that the cement and concrete products, the steel, the fired clay products, the timber, and the swimming pools we discovered are currently the most impacting materials to be locked into our builds as they rise from the ground. A couple of thumbnail sums and a good dose of critical and future thinking go a long way in guiding our material specifications towards environmental and social responsibility. So let's start with cement and concrete. The World Green Building Council again, Beyond Zero Emissions, and other respectable sources agree that the manufacture of Portland cement alone is not just all of concrete, just the cement that goes in. It accounts for a whopping 8% of the planet's greenhouse gas emissions. So that's roughly the same as the entire transport sector. It's hard to believe, but it's true. But there are alternative, equally effective and readily available concrete binders, such as fly ash, which is a waste from coal-fired power generation, and slag, which is a byproduct from steel smelting, that can be used as binders. They're alternative binders, and they're collectively referred to as supplementary cementitious materials, or SCMs. The Mullen Creek Design Guidelines required that SCMs make up a minimum 30% of the cement used in wet mix structural concrete. And some architects and engineers choose to increase that to around 60% where surface finish isn't critical. As construction commenced on the estate at Mullen Creek, we found that more and more local batching plants were supplying concrete with SCMs, with no increase to supply cost. In time, it should be considerably cheaper, we're told, by these batches, because slag and fly ash are problematic industrial wastes that are otherwise expensive to dispose of. The initial resistance to SCM subsided as concreters at Mullen Creek found ground slabs containing SCMs were stronger and with less shrinkage cracking. As the shotcrete sprayers learned to add water, not to add water so liberally to adjust the workability of the SCM mix on site. And as bricklayers and rammed earth wall contractors realised that bagged cement containing 50% SCM, such as Australian Builders Eco Blend, which is on the left of your screen, was equivalent to the general purpose Portland cement in both performance and price. My next job is to convince rammed earth wall builders that Australian Builders sound like a bit of a marketer for Australian Builders, but I'm not. That Australian Builders steel pave, being 85% white slag, will also perform well as a cementitious material without reducing those nice earthy wall colours to a drab grey. The other week, I was on the phone with a bright young architect from Stefan's office. His name is Rodrigo Roca. He recalled someone from, I think he mentioned it was someone from Austria, telling him that rammed earth in Australia, not Austria, is not rammed earth, but it's rather just dirty concrete. And he's right. There's certainly nothing environmentally responsible about building a 350mm thick rammed earth wall containing 10% Portland cement by volume. The mix for a 190mm thick hollow concrete block contains only 14% Portland cement, and the volume of this material that's going into that wall is hugely less, so much less impacting than most of the rammed earth walls that are going up at the moment. When I was a young bloke, we built a lot with rammed earth and puddled mud. We put effort into selecting and blending aggregate with the right gradation of particle size and colloidal content to achieve good strength and weatherability without the need for cement. We followed the CSIRO National Building Technology Centre Bulletin 5 on earth wall construction. And we did which is still not in print, but you can find it on the net. And we did the old-fashioned thing of erecting test panels before proceeding with each build. What about steel? I think there's nothing wrong with a piece of corrugated iron. Profiled sheet steel for wall and roof cladding provides an expanse of robust and almost maintenance-free cover that's difficult to surpass at less than half a millimetre of material thickness. That said, reducing the amount of weighty steel in construction is one of the best ways to minimise embodied carbon, because steel's carbon footprint, or virgin steel's carbon footprint per unit volume, is almost beyond compare amongst common building materials, which if you've got a magnifying glass on you, you'll be able to see on this table. You'll see steel is up around in excess of 10 times per unit weight. They have a similar density, but you'll see by per unit density or per unit weight or volume, 10 times the embodied carbon and embodied energy that go into them. It's quite extraordinary. In too many simple structures that I see, around the traps, I find there's steel used where substitution with a sustainably sourced timber would have been a cost-saving no-brainer. On some sites, it's almost obscene. These are architect-designed homes. The Mullen Creek Design Guidelines include a requirement that prohibits the use of cold-form steel framing, but the use of hot-rolled steel is permitted. I learned more recently, some years after we finalised the design guidelines for Mullen Creek, that the Currumbin Eco Village up in Queensland prohibited hot-rolled steel, and it did so without undue resistance. So in retrospect, I reckon we could have done this too. Nonetheless, the Mullen Creek Steel Products Guide, which you can find on the website, on the Mullen Creek website, lists steel products that are manufactured locally via comparatively energy efficient ISO accredited processes. Our local eco-warrior, Juice Backer, argues that steel is fully recyclable and so the ultimate framing timber. When the day comes that global industry draws solely on recycled steel stock and renewable energy for its resmelting, I might look to agreeing with him. But until then, and it looks to me to be a long way off, this climate and biodiversity emergency must have us desperately seeking to minimise the amount of structural steel we shove into our buildings. While working through some details for a reinforced concrete round slab a while back, I did a few simple sums and I realised that its embodied carbon could be reduced by increasing slab thickness to allow a reduction in the gauge of slab mesh. And you'd think that to be counterintuitive, but such is the potency of embodied carbon in steel that we need to address. We need to start questioning architecture on our drawing boards that relies on highly reinforced concrete and hot-rolled steel to stand up. We need to ask ourselves why such structurally demanding designs are necessary. Are we chasing building heights that are simply unsustainable, also by broader environmental and economic and social measure? Or has our architectural flair for gravity-defying cantilevers overtaken our responsibility to design light and lean in response to the emergency before us? What other less impacting materials could we use for these structures? And that brings me to timber. You'll see this everywhere. Wood is good, end of story. Make it wood. Contrary to popular belief and some heavy marketing, timber can be the very best or the very worst material you will work with as an architect or a builder, depending on where and how it's sourced. If it's sourced sensitively, it can store carbon through and beyond its service life in construction. It can be reused or recycled, or it can be harvested from deliberately planted and sensitively managed forest, and then helping to maintain healthy ecological processes, sequestering atmospheric carbon, and contributing to the social and economic well-being of rural communities. But timber that's harvested insensitively can result in serious and irreversible impacts on flora and fauna, on soil health and waterways. It can reduce or even reverse a forest system's sequestration of atmospheric carbon, and it can erode the well-being of rural communities. There's lots you can read on this. Even before our current bushfires commenced in September, deforestation was responsible for some 17% of global greenhouse gas emissions. And unfortunately, the bulk of structural and architectural timbers that we specify in Australia are sourced in ways that contribute directly and indirectly to this forest demise. The laundering of illegally harvested forest woods into massive and opaque timber supply chains, some of it with PEFC or AFS or even FSC environmental certifications. This stands as the largest illicit business on the planet, behind human trafficking and narcotics. Over the past few years, our Bunnings stores have transitioned their sourcing, not only Bunnings, but all the major timber outlets, most of which even it's the home builder, the commercial home builder will go to. They've transitioned their sourcing of softwood framing timber away from fast-grown radiata pine from temperate climate Australian and New Zealand plantations. And they're transitioning towards slow-grown Baltic pine from cold climate Russian and Eastern European native forests. Many architects, and I find even tradespeople on site, are not really across this. You can see that it's very easy to see the difference. Radiata pine grows fast in it, and you can see the growth rings are really quite far apart across a bit of 90 by 35. Look at a piece of Baltic pine, you'll see probably 100 years of growth just in a piece that's 90 by 35. These are being cut from trees of 200 to 400 years of age. The current rate of deforestation of Northern Hemisphere boreal forests, which is where they come from, that's the largest terrestrial biome on the planet. So you can see that great big green band in the Northern Hemisphere across there, across Canada and Europe and right through huge Russia. That's where this timber that we find in our Bunnings stores comes from, and it's being pulled out at a rapid rate and causing all sorts of other issues. You can see the dark purple colours where it's particularly severe, and red. So there's major net loss of forest cover in those areas due to the deforestation. That will have catastrophic impact on our global climate if it continues. Also in Australia, the logging of native forests, both legal and some illegal, drives biodiversity loss and ecosystem collapse. It also encourages pest, weed, and exposure-related tree dieback, which in turn exacerbates wildfire risk. These damaging impacts are now compounded by a hotter and drier climate. So this time last year, our country's high labour costs and slowly raising environmental concern saw at least a good portion of Victoria's remnant forest, native forest, protected from logging. Conveniently at those times, we turn again to tropical rainforests of poor Southeast Asian and Amazonian countries for our Kumaru decks and Merbau window joinery. Sadly, these days, a year has now become a long time for a native forest. In the wake of our horrific black summer, the Australian timber industry is now poised to mechanically thin those native forest reserves that remain intact. It's proposed in the name of fuel reduction, overriding state powers to decree by the decree of the federal government as an emergency response. Even architecture and design reckons this has got merit. Meanwhile, we have a chorus of world-renowned forest ecologists and fire scientists in Australia, such as David Lindenmayer, who's at the ANU, who draw on clear evidence from the field to demonstrate that mechanical thinning of Australia's tall forests will not lessen fire risk, but instead it'll increase it. The timber lobby is powerful, whilst the central tenet of the global movement to arrest climate and biodiversity collapse, the central tenet is to listen to the peer-reviewed science. As Australian architects who declare, let's make something good out of our bushfire tragedy and ensure through our specifications and site inspections that only timber sourced from trees purposefully planted on previously cleared Australian or New Zealand farmland, or what's recycled from prior constructions, that only that makes its way to our builds, onto our builds. This leaves many good timber choices across all architectural and engineering applications, and it sends a strong message to the now global timber industry that we need to entertain only fairly sourced wood. Mullen Creek requires that timbers be sourced locally in accordance with quite stringent environmental and social criteria. We compiled background papers and a comprehensive list of readily available timber products suited to all applications and budgets. So you'll find these documents on the Mullen Creek website. We're really pleased and a little surprised with how architects, landscape designers and builders are with minimal resistance embracing the sustainable timber products we're requiring them to choose from. And we know they're carrying this new product awareness to their other jobs. Also, this material that's on the web is finding its way into design offices that, other than those that have engaged with Mullen Creek, which is tremendous. This is a job of mine from a while back. It's a small library and a wildfire shelter for Candlebark School in the Macedon Ranges. It has a lot of wood in it, and it's all sourced from Australian softwood plantations and recycled hardwood. All of the main framing is obviously that's in LVL. It's grown in plantation in Western Australia, supplied by Wesbeam, and the windows are recycled blackbutt from an old warehouse in Sydney. You'll often hear that wood is sustainable because it's ultimately renewable and it sequesters atmospheric carbon. In this case, that's true. But how much CO2 is actually sequestered in this woody build? Well, it's 90 tonnes that I worked out of seasoned wood. It sequesters around 90 times 1.8 or around 160 tonnes of CO2. But that was only just covered the CO2 that was emitted in the manufacture and transport of the engineered timber products, the LVL and the plywood, together with the cement and concrete products for ground slabs and block walls, for thermoplastic drainage cells and waterproofing membranes, for the glass and the carpet, and making a nominal additional allowance for miscellaneous bits and bobs for this earth-covered building. And 160 tonnes of atmospheric carbon, they're emitted by an average Aussie family of 4 every 2 years. The simple arithmetic of this is really quite confronting. The past 4 years, we've been able to extend the timber initiative of Mullen Creek into a launch of a new social enterprise called Series Fairwood. The profits from Series Fairwood go back into Series Community Environment Park, which people from Melbourne and the women on this webinar will probably know. It's a wonderful place in Brunswick. Fairwood removes itself from the adversarial forest debate and from opaque environmental certification schemes. It aggregates and retails timbers inside short supply chains with tree farmers and portable sawmill operators who we know personally. They're mostly small producers who are geographically dispersed and struggle to find, sell and deliver to a market that fully appreciates the trees and the timber that we've got on offer. Fairwood buys only from growers and millers who source wood to the highest standards of environmental and social responsibility, being informed by the Mullen Creek project. We share their stories directly with our customers, which are building and landscape contractors, furniture makers and DIYers. Fairwood business builds direct friendships and understandings between city and country folk, and it encourages farming families to revegetate their bare paddocks with trees for conservation and for profit. I'm in the process of writing a paper on timber for the AIA's Environment Design Guide, and once that's done, I'd be happy to present again to Architects Declare on this subject of timber. For me, the only really disappointing thing about the Mullen Creek project was our failure to cap the scale of homes that were built there. There are some monsters on the estate in the peri-urban surrounds that it has. There are some monster houses on the estate, and the peri-urban surrounds, they didn't exactly provide commercial courage for such a move because there are lots of other big houses surrounding the estate. Another terrific infographic by Stefan and Crawford shows how in just 26 years, between 1984 and 2010, house size nearly doubled in Australia from 50 square metres to a gobsmacking 87 square metres per occupant. How much house is enough? And how much of the Earth's material and energy resources are needed to comfortably house an Aussie? There's nothing sustainable about an 8+ star 400 or 500 square metre house. Going forward, as architects who declare, can we simply refuse to serve clients who ask us to work on homes that already have or will have a floor area greater than, say, 60 square metre floor area per occupant or per bedroom? By now, some of you are probably hating me, I guess. Can we at least impress on our clients that quantity of construction drives precious material consumption and carbon footprint upward, whereas quality of construction calls on smart design and craftsmanship, on the good work of people rather than our planetary limits. Putting this concern about building scale aside, the Mullen Creek project will certainly serve as an exemplar for site-sensitive building and landscape design. It'll showcase energy efficient architecture and it'll promote the use of environmentally responsible building materials. So things that you'll see in place on the estate. But I think its bigger legacy will be in published and freely shared learnings, which are a welcome change from guarded IP, and in the advancement of people, so lot owners, designers, builders, who've been able to engage with the project. A good moment here for me to acknowledge the tremendous contributions of my colleagues and friends. Architects Brendan Pelham and Nayan Puri, engineer Jessamy Yule and Rafi Cruz, who teamed up with me on the Mullen Creek project. Rafi has a background in geology, beekeeping and climate change research. She's not an architect by trade, has been a particular strength. So much of what, I should say by qualification, she's not an architect. So much of what I've been able to share with you here about Mullen Creek and Ceres Fairwood is the fruit of her tireless and rigorous work method. Her extraordinary technical smarts, her intuition and her humanity. She also helped me to get this presentation together. So now to conclude, is that coronavirus curveball thrown into the mix. COVID takes the air from our lungs as we've logged and burnt the lungs from our earth. Affluenza fuels international flights and ocean cruises. If we fly to Europe once each year, that almost doubles our personal carbon footprint as Australians, for reasons I can explain later if anyone's interested. So infinitely more than what those Qantas offsets would suggest. And now these flights and cruises are prime vectors for this pandemic. A number of commentators in recent days have suggested we use this time to lay low and reflect on the poor environmental and social justice, the intergenerational burden and the sheer fragility that underlies current global economic systems, which we've worshipped or been battered by, depending on our life circumstances. But either way, we've done it for far too long now. I love this poem by Kitty O'Meara. You may have already read it. It's now gone viral via 350.org and possibly other ways as well. It elicits a range of responses. Some people cry with relief for the nature they love. Some fear that society is not as lovely as the poem suggests. And others worry for those who are too impacted by the crisis to stay home, to rest and play games. They're all quite valid emotions. Nonetheless, this gives our planet a breather, and it's our chance to again think globally and to act locally and to discover, to rediscover that small is beautiful. It's E.F. Schulmacher. Architecture that repairs the health of our environmental and social systems, it doesn't exist in a bubble. We'll struggle to genuinely practice regenerative design on a principled footing without also living regenerative lives that deeply and intrinsically reconnect us with nature and allow us to see things and feel things through the eyes and hearts of others. We can each find different ways, drawing on our individual capacities and experience and strengths to live such a life. To give you a better sense of what I'm suggesting, I can only share with you quickly about my own journey. As a child, I was gifted a sensibility for communal self-reliance from my extended family, which was of Templar German origin. And I was drawn to Ceres Community Environment Park in East Brunswick as a young bloke, as one of its founding members in the early 80s, and I never looked back. This background brought me the courage to take a sidestep upon graduating as an architect, to live and work with rural and remote Aboriginal and Torres Strait Islander communities in support of their aims, to design their own homes in ways that were meaningful to them, to build their own homes using materials which were freely available in the local bush, and to adopt simple construction methods which were suited to the community workforce, which were men, women and children, all with vastly different levels of skill and energy. Back in Victoria a decade later, I was able to follow my dreams. To reforest a degraded paddock in South Gippsland, to build an autonomous house in my spare time as I found the dosh to do it, to team up with neighbouring farmers and supporters from both the city and the bush to reforest our local valleys between Western Port Bay and the Basque Coast. We were able to plant 400,000 locally Indigenous trees and shrubs within a decade. That's what people power can do. I was able to follow in my grandpa's footsteps and grow fruit and veggies for my family, our friends, and for organic retailers, Series Fair Food, another social enterprise of Series, and to Terra Madre. This place, and it's where I am now, it'll always be my laboratory for learning, and it'll be a lifelong joy. So to you young ones Zooming with us, I'd like to assure you that there are lots of fun ways to be an architect. This suite of crises that we have in front can serve us up as many opportunities as constraints. We can skill up to this emergency most effectively by collaborating generously, not only within our profession, but also with absolutely anyone and everyone who's willing to play with us. Include our building user groups as central players in participatory design and construction processes. Let's influence and inform new aesthetic sensibilities that have us vomiting at the sight of wasteful opulence and excessive scale. Let's see us celebrate proud self-builders and that leave us in awe of creativity that can be born of hardship. We could even suggest that a green building is one that's already there. Together, let's delicately rework existing buildings where we can, apply our finest design skills to minimise natural resource depletion and to give our planet a chance to heal. Accept that a gentle architectural approach may not catch the eye of yesterday's, maybe tomorrow's glossy magazines, but know that future life on Earth will be thankful for it. So now might be the time for a revolution in architecture. And thank you, everyone. That's all from me.